In this part, we will discuss vector addition. Vector addition is a very simple process. Just think of adding numbers together. By adding these two vectors, we have a new vector of a length of 15. And the direction of the new vector will have the same direction of the two added ones. You can add as many vectors as you can, as long as they all have the same direction. Again, as long as vectors have same direction, they can be added together, and the new vector will also have the same direction. Now let's see how we can add vectors that have different directions. Now we will add these four vectors together. Notice that we have two horizontal vectors and two vertical ones. To add these vectors, we need the reference direction's coordinates. The first step is to add the two horizontal vectors together. This will result in a one horizontal vector with an amplitude of 8. The next step is to add the two vertical vectors together. And this will result in a new one vertical vector with an amplitude of 7. Now we need to add two vectors instead of four vectors. But these two vectors are not at the same direction, so we cannot add them directly. To add them, we need to employ one of the famous techniques. It is the tail-to-head method. Now what we need to do now is to create a vector that starts from the tail of the first and ends at the head of the last. This new green vector represents the sum of the two vectors. Using some simple math of the right angle triangle, we can calculate the length of this new vector. We can also take the inverse of 10 and find the angle that represents its direction, which is 41.2 degrees from the east direction. Now we can represent this vector by its own magnitude and direction. Let's now take the game to a higher level and try to find the sum of two random vectors. And it's better now to work over a reference coordinates system. First step is to draw the two given vectors. Then we will relocate the vectors to make sure that they will form a tail-to-head arrangement. We can simply do this by shifting one of the vectors into the other. One important step here is to know the exact angle between the two vectors. From math, we know that the 45 degrees angle can be reflected just as shown. So now we discovered the total angle between the two vectors. Now this black vector will represent the sum of the green and blue vectors. Based on the amplitudes of the green and blue vectors, and also the angle between them, we can employ the cosine rule to find the amplitude of the vector sum. And based on the sine rule, we can find the angle beta. Remember that angle beta does not represent the direction angle of the vector sum, but will help finding the direction. Based on beta, we can now find the angle gamma, which represents the direction of the vector sum referred to the negative x-axis. Let's move to another example and find the vector sum of four random vectors. Like what we just learned, we will shift the vectors to form the tail-to-head arrangement. The black vector represents the sum of the four vectors together. The sequence of adding these four vectors does not matter, as we will always get the same vector sum.